Today we will see integral literal. Okay, and yesterday we have seen about the what is literals and the types of literals, and we have discussed about the boolean literals, character literals, and string literal, right? Yesterday. So today we will see about the integral literals. Okay, fine. So basically integral literals are what? So the data, if suppose if you are defining some variable and the variable is of type either byte, short, int, or long. Okay, these are the integral literals. Okay, and if the data type is float and long, in that case, floating literals you can say. Okay, so these are nothing but the floating literals. So see here, these type. So for integral literals, this type of value will be used for integral data type: byte, short, int, long. Okay, if you are using integral literal directly, then by default it will be of type int. So whenever you are trying to assign any value to the int or maybe any type of variable, if you are trying to assign uh, the value to any integral type. Okay, these are the integral types, right? Integral types. So any of the if you are having the variable is of type integral type. Okay, so what is integral type? Byte, if maybe data type can be byte, short, int, or long. Okay, any of the data type if you have found. So if you are assigning the value to any of these variable, okay, then value will be always okay. So see here, whatever value you are passing, okay, if it is not floating type, if it is like if it is integral type, by default the type of this value is integer. Okay, remember this. So if you are trying to if you are using integral literal directly, then by default the type will be int type. Okay, if you are see here, byte v1 is equal to 12, so this 12 is integer type, but you are trying to assign it into the byte because this value can, so byte type of variable can hold this 12 value because the range of the byte is up to 127. Okay, and as soon as if you will give 128, immediately you will get the compile time error. Okay, because it is the out of range. Okay, and if it is out of range and the type of this is int and you are trying to store this int into the byte type, that's why it will give problem. Okay, similarly here also short sh is equal to 123 and you are trying to assign this integral literal. Okay, this is the integral literal, the type of this value is int type. See here, the integer range is up to here 2147483647. This is the maximum value of int. We will see how to find out. If I want to see, if I want to check through the through the program, I want to check how to what is the maximum value that int data type or maybe double data type or float data type can hold. We will see that. Okay, now to represent long literal, okay, by default whatever value you will pass, that will be the long that will be the int type. Okay, to represent that, this value you want to represent as long. Okay, so you have to use small l or capital L. Okay, so if you, so here it is not mandatory. Okay, it is not mandatory because if you are not using L or capital L, because it is in the range of int and already you are storing inside the int data type only. Okay, that means there is no problem. But suppose if you want to store this value into this, because it is the out of range, right? If you will try to store this value here in the int data type, okay, you will get the problem. Okay, so for that you have to change the data type, correct? So if you will make it as long, okay, then there will not be any problem. Okay, long can store the int value, there is no problem at all. But yes, if you will try to assign this value, explicitly you have to say L or capital L. Okay, remember this. Because it is out of integer out of int data type range. Okay, it is the out of range of int data type. So see here, small l or capital L you can use. Also, you can represent the integral literals as follow. Okay, So how many type of integer value you can find? Suppose something like this. If you are writing this value or maybe this value, okay, these are the integer type. Okay, 1 minute. Okay, and we can represent the value like this. We can represent, suppose if I want to represent uh, suppose 21, but not in decimal. This is the decimal form, right? This is the decimal form. I don't want to represent this value in decimal. I want to represent this value in binary. Okay, so first this 21 has to be converted into, I mean, first we can convert this into binary. What is the binary for this 21? Okay, so how we can find out? Let me just 1 minute. Two. Okay, so it will give 10, 1, 5, 0, 2, 1, and 1, 0. Okay, so what would be the value? The value would be 1, 1, 0, 1, 0, 1. Okay, this is the value. How to convert exactly, we will tell you. I'll tell you later. If you have the basic idea, then it's fine. Okay, so now, okay, so instead of, suppose if I will write int I is equal to 21. Okay, instead of that, what I want to write, int I is equal to this binary value. Okay, but if you will directly provide this value, okay, so your JVM will treat this value as it is 10101. So how much it will be? 10,101. So it will consider like this, but I don't want to consider like this. Okay, so whenever what I want to force to the JVM, that okay, this value, my JVM should consider this value as binary value. So how to do so? We can use the prefix called 0b or is capital B, 0 capital B or 0 small b. Okay, if you will write like this, okay, so whenever you will use the value, okay, I value, always it would be 21 only. Okay, we will see. Okay, clear. So we can represent not only in binary. If suppose I want to represent in octal, if I want to represent that value in decimal, or if I want to represent this value in hexadecimal. Okay, so all these value you can define. How to define? Because all, but remember this thing, all these are integral type only. Okay, so if you want to represent in binary, you have to use, okay, 0b and 0 capital B and the range of the digit. Okay, okay, so you can use with binary literal, always you have to remember you can use only 0 and 1. While defining octal, you can use only from 0 to 7. Decimal you can use 0 to 9, no problem. Okay, and for hexadecimal, 0 to 15. Okay, remember this thing, we'll see that. So for binary, you can always you have to use always 0 or 1. Okay, and to explicitly you know to explicitly saying that this is the binary value, you have to use one prefix called 0b. Similarly, you can use 0 and 7. Okay, in between 0, 1, 2, whatever you want to use, you can use. Okay, this literal will be used to provide the value. Okay, uh, in octal format. You can use the combination of digit of 0 and 7 for the octal literal, but you must start the literal with 0. Similarly, like it if you want to define this value as binary value, always you have to go for 0b option. Similarly here, if you want to represent the octal literal, always you have to start your value with 0. Okay, and whatever your, but the range you again you have to remember, range you always, it should be in between 0 to 7 only. So here 2, it's coming into 0 to 7, 4 is coming between 0 to 7, 5 is coming between 0 to 7. You cannot use like this. Okay, if you will use this, okay, we'll see that. See here, it would, I mean, compiler will give the problem. See here, if you will write byte b is equal to 0, 8, so 8 is out of, so you cannot use this 8 digit, right? In octal literal, you can always use 0 between 0 to 7. Okay, but here you are using 8, that's why it is invalid. Similarly, decimal. So this literal will be used to provide the value in decimal format. Okay, and you can use the combination of 0 and 9. Already I've told you. Okay, so these are the all, so this is a normal thing. Okay, whenever you are giving any value, that is the decimal value, right? Because you are using the number from 0 to 9 only. Okay, but you must not start the literal with 0. This is also the condition. If you are writing, if you want to define your value as decimal, no problem, you can define. But if you are starting with 0, then there is a problem. Okay, you must not, that means you must not start the literal with 0. This is the rule. Okay, if you are starting with 0, JVM will consider that value as octal value. Okay, and if JVM found this 383, it will immediately give the problem. Okay, so but if you will remove this 0, then it is fine, no problem at all. Clear? We'll see that with example. Hexadecimal, you have to always use the prefix 0x or 0 capital X, there is no problem. Yes, and one more thing, uh, I have told you that you can use the value from 0 to 15, no problem. You can use the value, sorry, you can use the numbers from 0 to 15. Always hexadecimal value, if you want to represent, always you have to use the prefix 0x or 0 capital X, whatever it is, and the range of the digit between 0, it must be between the 0 and 15. Okay, always it should be fall into this range only. Okay, now there is a one question in your mind. Okay, how to represent 14? Okay, how to represent 14? Suppose my number is 12, I want to represent 12 and 14 and 7, maybe 11. Okay, but if you will write like this 0x, okay, if you will write 0x, then the corresponding value of this is different, because it will not treat this and these two digit as a single digit. No, it will not treat this two digit, okay, two numbers as a single number, as a single unit. You want to represent this as 14, but JVM will consider 1 and 4 separately. Okay, and obviously these all the numbers are coming in the same range. Okay, so the corresponding decimal value would be different. Okay, corresponding decimal value would be different, but my requirement is uh, I don't want to consider, I don't want JVM to consider these numbers separately, 1 2 1 4 4 1 1. Okay, not like that. So for that, what you can do is, okay, so there is a pattern. What is the pattern? uh, if it is 10, if you want to represent 10, then use A. Okay, if you want to represent 11, use B. If you want to represent 12, use C. And up to which range we can use? Up to 15, right? 13, we can represent this 13 value from D. 14, E. And 15 we can represent as F. So now instead of writing this value, if you will write this, that is pakka valid, no problem in that. Okay, but if you will write like this 0x and 12, what you can write for 12? C, right? So you can write C. For 14, E, and for 11, B. Okay, now JVM will understand. Okay, so this is one hexadecimal value. Here also it will understand, okay, this is the hexadecimal value, but it will consider each digit. Okay, but here 0x and C value, what is the C value? 12, E value 13, B value 11. Clear? So the corresponding octal value would be considered. Okay, so is there any doubt, guys? Any problem by in understanding this? No, right? Now we'll see floating literals. Okay, so already we know what is the floating data types, float and double. Okay, So you can write the floating value in decimal format or in exponential format. Okay, so what is the exponential format? I think you know that by default the type of the floating literal is double type. Similarly, what is the type by default the type of the integral literal would be what? Integer type. Similarly here the default type for the floating literal is double type. Okay, so explicitly you have to, if you want to say that okay this is the float value, so you have to specify by using f, small f or capital F as a suffix, like how we were defining long value. Similarly you have to define as float value. Okay, so here if you will print system.out.println and this value if you will print, by default it's a type double type. Okay, but if you want to represent this value as float type, then you have to use small f also with it. Okay, clear? So you must have to write small f or capital F as a suffix for the value. Okay, optionally optionally you can use small d or capital D, because by default it's a double type only. Okay, if you will write D also, there is no problem. Ultimately you are trying to say that okay this is the double value, and the default JVM will by default understand this is the double value. Explicitly also if you want to say D, but this is optional. But F is not optional. If you want to mention that this is the float value, okay, you have to explicitly define that as a small f or by capital F. Okay, so as a suffix. So that thing you have to remember. Now there is one more literal called null literal. So null literal is generally okay. This literal will be used to provide the null value to any reference data type. Remember this. Okay, so this is all about the reference data type, because in previous case floating literals where we can use for floating data type, right? For floating data type, right? Integral literal we can use with integral data types, right? String literal we can use with string data type. Similarly null you can use with any reference data type. Okay, this literal will be used to provide the null value to any reference data type. Already we have discussed what is reference data type. Okay, any type, any user defined type or any class type or whatever it is. Okay, so whenever you are using any class name or any any type name, so the so you can assign null to that particular variable. The type of the variable is reference type, so so that's why we are giving null value. Okay, remember this, null value or null literal we can assign only to the reference data type, not with the primitive. Int is the primitive data type, right? There are 8 primitive data types if you remember. Okay, byte, short, sorry, byte, boolean, byte, character, short, int, long, float, double. These are the uh, primitive data type, right? So here uh, you cannot use null with it, because this is a primitive data type. You can always use null with the any reference data type, string, it can be animal, it can be text, it can be customer. So by default JVM will provide the null value, but it should be a global variable. Okay, or you can say for any global variable. Okay, for any global variable JVM will always give the default value as null. So but the condition is if the variable type of reference type, okay, if the variable type is reference type, then by default JVM will provide the null value. Okay, but it should be the global variable. Okay, so now we'll see some program, then you will understand better. Okay, so any doubt, any confusion guys, any problem, any question if you are having in your mind, you can ask that. Okay, now we will see some program. That is the boolean literal we covered yesterday, string literal and character literals, all those we have, all these things we have seen yesterday class. Now today we'll see So we are defining the main method here. Okay, if suppose if I'm writing int ab is equal to int is ab is equal, what is the maximum value, what is the maximum value of int? Okay, what is the range? So the range of int is 2147483647. Okay, so this is the range of the integer data type. Okay, now if I will print this, there is no problem at all. Okay, ab, clear? If I will try to compile it, test6.java. Okay, so here see this, no problem. Okay, java test 6. Okay, now what we will do, we will take this value here. Okay, instead of this ab we will write bc. Okay, and instead of this I will add this. Okay, then I will try to print this, or maybe before will it compile, guys? Can you please quickly confirm? Can we able, I mean, can we able to compile this? Abhinay is saying yes. Okay, Abhinay is saying again no. Okay, okay, so I think you know that why we are not able to compile. Okay, see here integer number is too large, it is out of range. Okay, so remember, if it is out of range, either way we can do. Okay, as of now we are not studying typecasting, that's why we can't do. But here something, if you will do like this, okay, that is a long value, we can't do this also. Okay, so here we write long. If we will write long, then there is no problem, I think. Okay, so here integer number too large, so this is the integer value, right? Integer number is too large, so this is not considering this value as long, so explicitly we have to say. So remember this if it is int, this line will give the problem. I am commenting it out, okay, for your reference purpose. Now if I will write same thing, okay, same only, but instead of this I will change the variable name, and if I will say this, okay, and this is 48. See here again we are not able to compile, see. Okay, so remember this thing, that is also not valid. Okay, now what we can do, val2 is equal to same value, but any suffix we can use l or small l, no problem in that. Okay, so now it is able to compile, because uh, because it is not able to compile because the value is out of range of integer type. Okay, now this is out of range, this is not int no more, it is not a int value. Okay, so explicitly you have to say this is long value, otherwise which value it should, I mean JVM will consider which value. JVM is in confusion because it is not in the range of integer. Okay, then which value it should consider, whether it can consider short, long, or I mean what it will consider. So that's why explicitly you have to tell that this is the long, right? Not only this, more than anything, I mean more than this value, whatever you will try to assign to the long data type, you have to always explicitly say, because this is not, so long is not a default type, that's why explicitly we have to say as long. Okay, now if I will write system.out.println, system.out.println, and this is the integer range, right? If I will try to print directly here, okay, so there is a difference between these two. Okay, so I think you got it, in the previous class we have discussed. So for this AB variable, okay, AB variable will take some memory location, memory inside the, JVM will allocate some memory for AB variable. But here directly value you are printing, okay, that means JVM has to just print this data onto the console. JVM will not allot the memory for this thing, okay. Now see this, no problem at all. Now same thing, but only one difference that I will do, system.out.println. We will do instead of this, if I will now tell me guys, is it valid or not? It is valid or not? Will it compile or not? Tell me guys. Okay, okay, it is valid. Let me check here whether it is valid or not. See here what it is telling. Integer number too large. Okay, so what it is treating? Okay, so this is the, it is treating this as integer value. Default type for all integral literals is integer type. So this is also JVM is trying to consider this as an integer value. Similarly here, right, JVM is trying to consider this as integer value, but this is out of range. Okay, if it is out of range, then you have to explicitly say that this is some, there is some another type. What is that? Small l or capital L you can use. Now there is no problem. Okay, remember this. You cannot print the value also directly like this. You have to define the type. So that is okay, that is not valid. I'm just commenting here. Okay, now if I will write something, okay, something like this, system.out println, and if I will write plus 100, guys please tell me, it is valid or not? It is valid or not? Why it is invalid, Abhinay? Any other guys, whether it is valid or not? Yes, valid. Okay, what about Akanksha, Soumya? Okay, maybe she has dropped. Okay, so we will check it here. That is pakka valid. Yes, because both values are int type. Okay, and remember this, for this there is no memory allocation, that's why there is no problem at all. These are the integer types only, right? It is in the range. This is the int value, this is the int value, and the what all JVM has to do is just add this value, and nowhere we have to store, nowhere JVM will store so that there should be any problem. No, JVM will not store these values. The JVM will not store the addition of these values anywhere. That's why there is no problem. Correct? Any problem? So whatever addition will come, okay, immediately it will print onto the console. That's it. Okay, that's why there is no problem. Get it guys? Clear? Any doubt why it is valid? Okay, now there is one more thing. If I will do something like this, 100L, now it is valid or invalid? Tell me clearly whether it is valid or not. Reply fast, guys. I'm having a lot of programs, that's why. Okay, all everybody is saying valid. Yes, so it is valid only, there is no problem. See, okay. So remember this thing. So for these values, okay, no memory allocation required. But only thing that you need to remember is the default integral literal types is integer type. And make sure at the time of compiling, okay, this value it should be into the range of the integer value. That is not in range, explicitly you have to define the type of the value. So that's why we are using L here. But here no need to use L because already it is integer type and it is in the range of that, right? So remember these things. Now if I will write long some val something value 1, okay, equal to 4 5 2 5 8. Okay, now let me just print it here. Okay, see here. So for this line, okay, for this line it will it will just add this value and the corresponding after this add, how come it will come and how it is coming we'll see later, but like this it will print, okay, for this thing, because it is out of range of integer type, that's why. Okay, and for this there is no problem, as it is printing, but for this it will print this. Okay, and here if you are using L, okay, that means you are storing, see here, 647 plus 100 747, right? See here 747. But if you are doing L here, that means you are saying this is the long literal, and if you are adding one integral literal with long literal, so your output will be converted into the long literal. So automatically this corresponding value would be can be stored into the long, right? But it cannot be stored inside the integer or not. Let me check it here. Control C. I'm just copying this value, and if I will try to assign it here, this is the int. Okay, and if I will try to assign this value here, okay, it will not compile. See here, so the value is too large. But already you told 100L, that means it's a long value. So one is long value, one is integral value, so the outcome will be, will become into long type. That's why if we will try to store this value into long, there is no problem. Okay, 1 minute, let me, yeah, again you have to explicitly say this also. Okay, no problem, correct. So remember this, but for this, okay, it has been typecasted. So whatever value 100 plus this, that is 747, correct, this is the value, but it has been converted into int type. That's why if you will write int and if you will convert that into int, okay, now let me show you, okay, why it will print. Okay, see here, again it printed the same value, right, whatever printed here, correct, because this is the long value. And if you will typecasted this value into int, then again it will print the same value. That is what here it is also, here it is going on. Okay, I will copy this here and print it here. Okay, so for your understanding purpose, clear? Any doubt now? As of now you don't know what is this typecasting, we will discuss this thing at a later point in time, but try to understand what's going on here. Okay, now if I will do long integer cd suppose, and one is equal to 45258. Okay, so already you know this is in the range of int only, correct or not? This is the int value, because by default the type of the integral literals is int type, no matter in which no matter which data type you are assigning, but this the value, the type of this value is int type, correct? So you are trying to assign into long data type, correct? We can do it, we can do this also, there is no problem. Okay, so there is, you know, automatically higher, so higher type can hold the lower type value, but lower type cannot hold the higher type. For that you have to go for explicit typecasting. That is what we are doing here. This is a long value and we are trying to assign long value into int type. That's why explicit typecasting is required. But here long is the higher type, int is the lower type. You are trying to assign int value into lower into long, so there is no problem. Long, I mean that higher type can, you know, hold the lower type value. Okay, if you will try to print also, what it will print, I will tell you. Well, 1. Okay, now see as it is, no value lost. But here in this case, okay, value, the, you know, value has been lost, so we have lost some values. That's why there is loss of precision. Okay, exact term is, there is loss of precision if you are trying to assign higher type into lower type by using explicit typecasting. In that case we can lose our value. Okay, but in the higher type you can assign lower type, then there is no problem, you will not lose your value. But here higher value you are trying to assign into lower I mean lower data type, so that is the thing. Okay, don't worry guys, you have to be have some patience and, you know, do some practice, then you will understand better. Okay, now suppose if I'm having long data type, value 2 is equal to 45258 L, then also there is no problem, right? Explicitly you are saying that this is not int value, this is a long type value. Long you are trying to assign into long only, no problem. Okay, then also there is no problem. Okay, in both the cases. Okay, what it is the what it is saying, variable val2 is already defined. Okay, let me just change here. Val2 is already defined. Okay, fine, that's why instead of this val3 will do. Now compile, no problem, test 6. Okay, see, there is no problem. Okay, instead of this val2 we have to print val3. Okay, no problem. Now what we will do, now we have to print. Okay, we will see what is the minimum value for each data type and what is the maximum value. Okay, remember this thing, always we have to, I want to print. Okay, we will start from byte. So for byte there is a class, there is a predefined class called byte. Okay, which is present in Java. We will discuss each class in detail later, but as of now just remember it is starting with the capital letter, that means it is a class only, correct? So if it is the class, there is one static property, that's why we can be able to fetch that property directly by using the class name without creating the instance. If you don't know this this line whatever I told you, okay, directly this property I am accessing through this byte class, because this property is static. Okay, what is the meaning of this line? We will discuss this thing in later when we will discuss the static variable and instance variable. Okay, but remember this, min value and max value, okay, these two are the constant. See here, min value is the constant. That's why it is in capital letter. Already I told you the naming convention, right? So always, whenever we are trying to, define any constant, always it should be capital letter, and it has to be separated with the underscore. Already I have defined the rule, right? Already I have told you the rule how to define constant. So there is a constant defined inside this class. Okay, directly we are accessing because this constant is static. We will discuss that. Now there is one more constant called max. Yes. So for each data type, uh, for each you can say the primitive data types. Okay, for each primitive data type there can be corresponding class also present. Okay, for byte data type there is a class called byte. For int data type there is class called you know integer. Okay, now we will discuss one by one: short, min value, and short, max value. Okay, so we will see what is the minimum value for byte, what is the maximum value. So it will specify the range. Okay, so I will write system dot out dot println. Okay, here I will write a range of all data types, all you can say primitive data types, all the primitive data types. We'll see. We'll compile it, no problem. Now see here, range of primitive data type. Okay, for byte minimum value is -128 and maximum is 127. You can assign only these values from -128 to 127 in byte data type. For short, -3276 to 3267. Okay, now we will see for the integer. Integer. Then long. Then double float. And double. Now try to compile it. No problem. Okay. See here. For byte, this is the range. For short, this is the range. For int, this is the range. For long, this is the range of the long. Now see here, for float, 3.402825 E38. That means 3.4 into 10 to the power 38, because it is showing as an exponential. Okay, it is the exponential type. That's why you are able to see this. 1.4 into 10 to the power minus 45 to 1.7 into 10 to the power 308. That is the maximum value of float. Is the minimum and maximum value. Okay, that is the minimum. Okay, so now you got it, minimum and maximum. Similarly here, minimum and maximum for double. Okay, so any confusion up to now? So if you okay, so don't worry if you're not understanding what's going on here, how it possible. No problem. Don't think too much about it. But yes, whenever, as of now, just you remember, if you want to print the range of any data type, any primitive data type, okay, so there is a corresponding wrapper classes has been given. These are the wrapper classes. So all the primitive data types corresponding wrappers classes are given. Okay, remember this. So as per that, you can use this constant. All I mean, each class is having this constant, min value and max value. So just we are printing the constant value, that's it. Okay, so now we will see that binary literal. Okay, we will start the binary literal. System.out.println. Okay, binary literals. Okay, now int ab is equal to 101. Suppose if I want to, okay, so let me, ab is already defined. Okay, what I will do, I will take one more class. I will take one more class. Okay, int ab is equal to 101. Okay, so already you know what is the type of 101. It's an integral date, integral value. Okay, system.out.println, there is no problem because it's in a range of integer and we are trying to store inside the integer data type only, that's why there is no problem. Okay, no problem. Java test 7. Okay, now what we will do, we will write, can we do ab plus 3? How much it would print? Correct, no problem. Now I will, this time I will assign one binary number 0b. If I will not use 0b, if I, because here 101 same I will take. Okay, same I will take, and you know that what is the value of this ab is 101 as it is. Already you have seen 101, right? It is 101, correct? And if you will add 3 into it, 104, no problem. Now what I will do, I will take the same 101 only because 101 it is. Okay, remember I will use here because now it become binary. We can use only 0 and 1. Okay, now you try to print it, what it will print. If you will try to print it, what it will print, guys? 5, correct? Because 101 is the binary for 5, that's why you are getting 5. Okay, now if you will do the same thing with bc, then what you will get? See here, 8, correct? That's how it is going on. So remember this. Suppose if I am having byte by1 is equal to 0b, okay, 10101. Now I will try to print b by 1. Okay, if it is in the range of byte, then there is no problem. Okay, it is the range it is in the range of byte. What is the value? 21. So 21 is the range, it is in the range of byte. Now what I will do, short x by is equal to 10234. Okay, 10234. So now, but can we write like this, guys? Please confirm. Mn is equal to 0b10234. Can we write like this, guys? Any doubt in this? What will happen? Can you please tell me? It is valid, it is invalid, or whether our program is compiled or what? Can you please tell me? Invalid. Okay, correct. Because we cannot use, you know, other digit apart from 0 and 1 if you are explicitly saying that this is the binary. So it is invalid. It is invalid. Now what I will do, I will write long. Okay, some very big number I am writing 0b. Okay, now okay, what is the corresponding value for it? What is the corresponding decimal value for it? Okay, is it valid, guys, or not? Tell me. It is valid or invalid, or our program will compile or not? Tell me. It is valid or invalid? Okay, see here. Okay, semicolon is missing. Semicolon, we have to put it here. See, okay, it is compiled. Now we will print it. Now we will print it. So we will do system dot out dot println. Well, we want to see what is the value of this binary number. Okay, now let me compile it here again and check. See here, test 7. What it will print? See, this is the decimal number. Okay, for this decimal number, this is the binary value for it corresponding. Okay, this is the binary value for that particular decimal number. So it is valid. There is no problem at all. Okay, now what we will do, I think there is no problem, right? Then we'll see for, you know, this is about the binary, right? System dot out dot println. It is for binary literals. Okay, now we will see the octal literal. Octal literal. Octal literal. See here, byte can be write like this: byte a is equal to. Now which prefix we have to put if we want to define octal value. Okay, which prefix we have to use? Can you please tell me, guys, which prefix we have to use if I want to define octal value? For binary, what we need to define? 0b or 0 capital B. But for octal, yeah, for octal, what we need to define, Ullas? 0 only. Okay, remember this. If we will write 0 1 2, okay, don't think that this is 12. Okay, if you are writing like this, JVM will understand, or JVM will treat this value as octal value. System dot out dot println. See here, if I will print A, what it should print? It will print the corresponding decimal number. For that, it is compiled and corresponding decimal number would be printed. This is 10. For 10, this is the octal value. Okay, how to convert from decimal to binary, how to convert from decimal to octal, how to convert from decimal to hexadecimal, or vice versa. Okay, that part uh, we will discuss, okay, later point in time. Okay, but suppose if I want to represent octal value, in that case you have to use 0 as a prefix. Okay, if you want to represent your binary, you have to use 0b as a prefix. Okay, but make sure if you are using octal, then the digit always you can use from 0 to 7, but for binary only 0 or 1. Correct? So this thing you need to remember. Okay, now what I will do, I will write one number. Okay, int, you have to tell me int b is equal to 0 9. Okay, now tell me what would whether it is valid or invalid. What is the corresponding decimal? I mean, whether it will print decimal value or not. Tell me, guys, quickly confirm, please. Int c is good. Confirm, please. 7676. Okay, so what will it print? System out println c. Now tell me, guys, whether it is valid or invalid. Ullas is saying valid. Okay, and Akanksha is saying decimal value as 9. No, suppose forget about these two lines. Okay, I'm talking about this line. Okay, now tell me, Akanksha, for this whether it is valid or invalid. Valid. Okay, see here. Integer number too large means ultimately that is not valid. Why? Because already you used 0 as a prefix. If you are using 0 as a prefix, that means you are indicating to JVM that whatever value I am going to specify, okay, that is nothing but whatever value we are going to specify, that is nothing but the octal value. That's why we are using 0 as a prefix. And the condition while using octal literal, you have to use the number between 0 to 7. Okay, that's why it is invalid. Okay, okay, just be, I mean, put some more attention here. Okay, that is very important. Okay, now see here, int c is equal to 07676. Now you tell me whether it is valid or invalid. Tell me guys. Okay, it is valid only, right? What is the problem? We are using 7676, no problem, within the range, and 0 as a prefix, so that means you're indicating octal, and this is a range in octal only. Okay, so int c is equal to this. There is no problem at all. Okay, remember this. Clear? Java test 7. It will print the corresponding decimal value. Okay, so I hope you understood. Okay, now if I will write simply if I will write d is equal to d is equal to, okay, then what it will print, whether it is valid or invalid. Now tell me. And what it will print, if it is valid, what it will print? Yes, it will print 7676 only. There is no problem in that. Oh, sorry, 7. Okay, clear guys? So that is all about the octal literals. Now we'll see the hexadecimal. Hex hexaliteral. Or before that, let me just write it here as decimal. Decimal literals or values. Okay, decimal literals. Already you know the range of decimal is from 0 to 9. Okay, int m is equal to 98987789. System dot out dot println and m. Okay, so what it will print guys, so already you know, so this is in the range of 0 to 9, and you can use, but it must not start with the 0. This is the condition. Okay, you can use 0 to 9, no problem, but 0 you can use always in middle, not from starting. If you will start 0 at beginning itself, that means you are indicating that is the octal number, and you have to follow the this condition. Okay, so you can use 0 to 9, there is no problem, but you must not start with the, you must not start with 0. Clear? Remember this. So whenever I'm writing in 23 123 something, okay, we are not starting with 0 now. We never started with 0, right? That's why we haven't observed this thing. Okay, now suppose if I will write byte b by 2 is equal to 1 2 3, b by 2 is equal to 1 2 3. Now if I will try to print b by 2, okay, then what it will print? Same only, right? 123. Okay, something like this. So there is no problem, right? Now we will see hexadecimal. Okay, we can say hexaliterals. Hexadecimal literals, 0 to up to 15. 0 to 15. Now see here, if I will write int rt1 is equal to 43a65. Okay, either is it valid or invalid guys? Tell me quickly. Invalid. Why it is invalid, Akansha? Avana is saying valid. Ullas, cause of A. So I already told you, suppose, okay, for this, maybe if I want to represent, this is 4 I want to represent, okay, because 0 till 0 to 15 I want to represent, okay. If you want to represent from 0 to 9, there is no problem, right? It's a single digit. But suppose if you want to represent as 10, okay, 10 is a single digit, then in that case you have to use A. If you want to represent 11, then you have to use B. If you want to, represent 12, then you have to use C. If you want to represent 13, then you have to use D. If you want to represent 14, in that case you have to use E. If you want to represent 15, in that case you have to use F. Correct? Yes, your answer should be this one, because this literal is not starting with 0x. That is the problem here. That's it. Apart from that, everything is fine. If you will put 0x here, then if you will try to compile, there is no problem. But if you will remove this, then it is treating this value as decimal value, right? Then it will not identify what is A. Let me see here. Error. Okay, semicolon as well. I mean something. Some semicolon is expected. Okay, and it is found A. So some error you will find. Okay, got it. So you have to use 0x. That is the problem. If you will say here, then there is no problem. Now you try to print it. RT1. Okay, then you will get the corresponding decimal value. What is the decimal value for that? 277093 for this 43A65. See here, 277093. That is the decimal value. How to calculate and how to convert this, that we'll see later. Okay, any doubt, guys? Clear? So first thing is that if you are not using 0x, that is invalid. Let me write it here. And if you will write it, int rt equal to 43a65, no problem, but you have to use 0x. Okay, and here with rt. Clear? Now if I will write byte by3 equal to, if I will write, or suppose if I will write it int cd is equal to 0x. Okay, not okay, let me, okay, that is done right by, okay, so rt is equal to 43. Fine, let me show you byte. If I will try to use 0xf, tell me, guys, is it valid, invalid, or what, whether it will compile or not? Hmm? Whether it's valid or invalid, guys, tell me. Okay, see here, it is valid, no problem. The actual value of this is decimal value 15. Okay, so that is all about the byte, I mean that hexadecimal literal. Any confusion, guys? Okay, now we will, you know Okay, so suppose if I'm writing double d1 is equal to, already I have told you this is about the floating literal. Okay, hexadecimal, hexaliteral, octaliteral, binary literal, integral literal, all we have completed now. Now we will see floating literals and null literal at last. Okay, so this is floating literals. So first we will write it here, system dot out dot println. Okay, floating literals. Fine. Now we will write double 6547 dot 7822. Clear? So we'll write, already we know by default the type of any floating literals would be double type. Okay, so this is by default double only. How it was in integral literal, what is the default type there? Integer type. Similarly here for floating literal the default type would be, for value it is double type. Okay, okay, you can define like this all. Okay, 1 minute, you can define like this also, double d2 is equal to 65.477822 e2. What does it mean? That means you have shifted this point to left side. Okay, that means we are multiplying by 100. If you will multiply by 100 into 100, okay, then, or maybe, yeah, 100 only. If you will multiply, not multiply also, divide by 100. If you will divide by 100, how much you will get? See here, if I will print d1, 65.7, if I will divide it by 100. Okay, that means in this case point is shifted to 2 point left side, right here. So we can write 65.47 into 10 to the power, how much? See here, 2. Okay, 10 to the power minus 2, you can say, not minus 2, it is 65.47 into 10 to the power 2. Okay, then only it will come earlier one. Okay, fine. That's how you can write like this also. E means 10 to the power. Okay, so it's an exponential form of this value, floating value. Okay, now we will see, we can write like this also, double d3 is equal to, we can write 654,778.22 e minus 2. That means into 10 to the power minus 2. Okay, clear? Now we will print system dot out println. Okay, we will remove this line, cut this out. Here we will print this d2 and d3. If it is 10 to the power minus 2, that means point will be shifted to 2 point left side. Okay, and if it will be 10 to the power 2, that means point will be shifted to 2 point here. In all the cases value would be same. See here, in all the cases values would be same. Why? Because first time this value as it is, no problem in this, because you are not doing anything. Now here what you are doing, 65.47. Point is shifted to 2 point here. That means you are multiplying. You are multiplying 100. You are Okay. So that's why if you are multiplying, that means point would be shifted to right side. Now what you are doing? You want to, because here 65 point. So here 654,778.22 into 10 to the power minus 2. That means point would be shifted to left side. That's why it came here. In all the case, values would be same. Okay. Now we can, okay. Now we can write it like this. Double D4 is equal to 123.456. Okay, double D5 is equal to 123.456. D also we can write optional. It is optional. Okay, already it is double type only, and D is also indicating the double type. Okay, no problem there. Okay, no problem. We can also represent, okay, D is equal to 123.456 small d. Then also no problem. In all the cases, value would be same only. Okay. Now we will print this value out here. Then you will get same D4, D5, and D. Okay. We'll see. Okay. Now we will see if we will write float f1 is equal to 123.456. Now tell me guys, it is valid or invalid? It is valid or invalid? Quickly guys, please respond. Abhinay is saying valid. Akanksha is saying valid. Okay. Okay, what about Ullas? What you are thinking? Valid. Okay, valid only. Fine. Okay. If it is valid, then why it is giving error? See, incompatible type, possible lossy conversion. Okay, precision loss of, okay, precision losing from double to float. By default, the type of the value is, by default the type of the floating literal would be double type. Okay, and you are trying to assign into float, so it is not a float value. Okay, what you can do here is you can either typecast it. Okay, if you will typecast it, then your value, you will lose your value. See here, because double type, your double type value you are trying to store inside the float type variable, right? See here, 1 minute, let me just print it out here. System.out.println. Okay, f1. What is the problem? Okay, spelling mistake it is. Println. Okay, Java test 8. Okay, so either way you can do, or what you can do here, so that is invalid first of all. Okay, it is invalid. Now you cannot write like this. Now if you want to do this, you can write like, you have to define explicitly 123.456 is float type. Then you have to mention it as, you can use small f or capital F, then there is no problem. Okay, we will later we will study about the typecasting, but here I'm not just specifying here. Now what I can do here is float, we can store float f. Okay, so you can say this is f2, one point 2, 3, 4, 5, 6 E2F. Okay, because f I'm mentioning at last just to represent the floating value. Apart from this value, okay, this is the your you know uh, floating literal. Okay, so if you will not use this f, you will get the compilation error because the value would be of type double. Okay, value would be of type double. Here also you have to use f2 instead of f1. Okay, and here you have to mention either small f or capital F, then there is no problem. Okay, Java test. See here. Oh, what it is? Oh, sorry. Test 8. Okay. Now we'll try to print system.out.println f2 and f3. Okay, f2 and f3. Fine. Now what we can see here, so that is all about the floating literal. Okay, now we will see the null literal. This is null literal. Okay, so we can write like this: string st is equal to null. Okay, string st is equal to null. What is the class name? Test8. Our current class name is test8. T is equal to, or test is equal to null. Okay, remember this. If we will define array, later we will study about the array. That is also the reference data type. Okay, remember this. Okay, array is the object. Okay, array is the object, but suppose int I is equal to 10. Int I is equal to 10. Okay, so I is primitive type. Okay, it is not object type, it is not reference type, it is not okay, it is not, you can say, reference type. Okay, but here array is the object, but I is the primitive. Okay, remember this. So if I am trying to store any object, okay, so if it is object, then the corresponding memory location also would be there. Okay, if it is the object, it would be created inside the heap, and if it is created inside the heap, then there is some address, and that address would be allocated to this arr variable. Okay, so remember this is also reference data type only, it is not primitive. Okay, it is the reference data type because it's a object. Now if I'm using integer instead of int, there is corresponding wrapper class is there, right? In earlier I have told integer, so it's a class, right? It's a class type, right? If it is the class type, then we can assign the null to it all. I mean, we can assign null to integer type also. Okay, but no, we can't do int I is equal to null. We can't do like this, that is invalid. Okay, we can't do like this. If you will check it here, see, you will get it. Incompatible type cannot be converted to null, to int. Okay, null cannot be converted to int. Remember this, so that is invalid. But if this is the wrapper type, okay, so it become type now. Okay, it become class now, so that's why it's a reference type variable. So any reference type we can use the null literal. Okay, now we will try to st. What will it print? St. And if I will print system.out.println, okay, and if I will print test, then it will print, and we will see, we will again print st test arr. Okay, and n. and all these values in all these variable, which value we have assigned? Null. Okay, we'll see. There is no problem. Java test 8. Okay, all the values null. Clear? Now some more thing that we will see here. Okay, or maybe this much, and then let me create one more example. Test 9 dot java class test 9. Okay, suppose if I want to try, if I want to convert integer to binary, okay, through the in the programmatic approach, okay, I'm not saying that you convert from integer to binary manually. No, you don't want to do it. Okay, I don't want to do it. Programmatically, I want to convert from integer value to binary value. Okay, so suppose I'm having int ab is equal to 87678. Okay, now I want to convert this ab value to binary. So what how we can do? So binary literal binary string I want to get. Okay, so 1 minute before that, let me just tell you, there is one class already we know, integer. What I want to convert? Integer I want to convert. I want to convert integer to binary, so there is one wrapper class called integer. Okay, and there is one static method inside this integer class called to binary string. There is one method. See, there is, see the camel casing here. Okay, this is the camel casing, right? They are also following the camel casing. See, so to binary string. So there is one method. Okay, and pass this ab. Pass this ab. If you will pass this ab as a parameter to this method of the integer class, okay, then you will get the binary string. You will get the binary string, something like this, something 101010. So this is become string now. So something like this. So you want to get it somewhere, right? So you are getting binary. Okay, but what is the type of this binary? You will get string type, right? Something like this. Remove this. Get it? Now we will see test9.java. No problem at all. Java test 9. Okay, so let me print it here. System dot out dot println bin. Okay, and run it. See, this is the corresponding binary for this number. For this number, this is the binary. Okay, you will get. Okay, clear, guys? Now I want to convert this into octal value. Okay, so again octal in string I want. Okay, string octal. So integer, there is one class integer dot to octal string. I want octal string, right, of ab. Okay, so okay, let me just do it at a time, and I want to convert into hexadecimal. Hex integer dot to hex string. Okay, these are the functions, and convert the ab. Okay, and now print all these bin oct and hex. See the value. This is the binary for that number. This is the octadecimal. This is the octal string, and this is the hexadecimal. And this is converted into hexadecimal number. Okay. So all these. Okay, all these. This is the binary. So it will give you the binary. Now this is the octal. will give you the octal, and this is the hexadecimal. Okay, so remember this. This is the way how you can suppose. Now guys, can you please tell me if it is the float value and I want to convert the corresponding binary, octal and hexadecimal string? In that case, what you will do, what you will write here? Can you, can anybody tell me if this is the integer value, right? If suppose if I'm having suppose if I'm having float bc is equal to vc is equal to 156, okay, 156.78, suppose this is what and okay, this is the value. Now I want to convert this bc value into, you know, binary, octal and hexadecimal string. Okay, how to do this? Abhinay, only float mandatory mark f? No, the rule is the default value is double. Okay, the default value is double and you are trying to store inside the float. So always you have to consider this. You have to, you know, explicitly say that no, this is not double, this is float value. That's why f is mandatory. Similarly here, this is the int type, but if you want to represent this as a long, always you have to write l. That is the reason. Got it? Okay, now Akansha is saying float dot to bind. Yes, exactly, you are true. So for any, actually for int value, integer class we have used. For float there is corresponding float wrapper, right? So same code I am writing here. Binary one, octal one and hexa one, instead of integer float. Okay, we have to just write it. That's it. One, one, one. Clear? Okay. Float dot to binary. Okay. Let me check it here. What it is saying, there is no method like this. Okay, there is no method of to binary string. What it is saying, Java, okay, test9 is the source file. Okay, line number 14, there is one error. What is the error? Cannot find symbol. Okay, cannot find symbol. What symbol it is not able to find? To binary string. Okay, what symbol? Symbol is method. What method? To binary string. Where location is class float. So in this class float, okay, JVM is not able to find one symbol called method. The name of the method is to binary string and it present at line number 14 in your Java code. Okay, which it is not able to find. Okay, let me see here. Okay, so if you remember guys, Akansha, have you have remember that you asked that question, what is the use of Java P, right? So now we will check, okay, whether the method is present inside the double or not. Let me check it here inside the float class. Okay, there is command called Java P, and we have to write float class. Okay, float. I want to know what is there inside this float class, but directly if you will write, it is not able to see. Okay, you have to write the fully qualified name in the sense the class where it is present in. Okay, so you write the package name also, in which package it is present. So already we know under java.lang.float is the class, right? Press enter. So see here, this is the entire information about the, this is entire API about the float class, correct? Compiled from, okay, so float.java, the source file name is float.java. Okay, and class is float. Okay, the class is public final class float. It is extending the number type and it is implementing the comparable interface. We will see that. Okay, and these are few constant. Okay, if you remember, these are two constant, max value and min value. Okay, I have already shown you, I have already used this value, right? Earlier example, max value and min value, correct? So these are the, so from here all these are the uh, final, right? All we are using final here, so these are the constant, correct? Now public static, there is one method called toString. It's okay. There is one method called toHex string. okay, to hex string, no problem. But there is no method called to binary string and to octal string. Okay, so is there any method available? Value of parse is none, infinite float. Okay, so there is no method available like this. Okay, so that is why you cannot, because for floating value you can't get the binary, right? So that is the thing that you need to remember. That's why they haven't provided this method. And for an octal also you can't get. Okay, hexadecimal you can get. Okay, we will see, because here also one method present called to hex string. That's why that is valid. Okay, now we will comment these two lines, and uh, these two line also we have to comment because we are not using these variables. Now we'll see. Now I think you got it. What is the use of Java P? If you want to debug more, that is very useful. Okay, so this is the hexadecimal value for this float value. Okay, clear guys? Okay, okay, now we will see. Okay, lastly, system dot out. How many of you are having some basic knowledge of C? If anybody knowing about this printf function, have you heard about this printf function? It is there inside the C language. Correct, Ullas? Anybody else? Have you heard about this printf function in C? Yes, yes. Scanf, printf, yes, all those. So these functions are also present in Java. They have provided C function also here. The name is same. You can use system.out.printf. Okay. Now, but the way of writing is different. How it is? See. So, okay. So if you will write something, if you will write hello, hello here, okay, and then if you will write hello Ullas, okay, hello Ullas. Suppose now you will try to compile it here. Now you run this test 9. See here, there is no next line, right? Hello Ullas, and again it is not went to the next line, right? And same line it's printed here, right? Okay, so cursor is in the same line. That means, so now you have to use /n. Okay, okay, so what it will do, if you will write /n, immediately it came to the next line. Okay, here also you use /n, then, but in println you never bother about this next line. That's why they have given, instead of f they have given ln. Ln means next line. Okay, clear? Okay, so we will compile, we will run it. Okay, now hello and again Ullas, right? And at last also if you will use /n, that means the cursor will go to the shift to the next line. See here, hello Ullas, and cursor is here. Okay, next line. So if you want to print, okay, if you want to print uh, decimal value, hexadecimal value without using this function, okay, then directly you can write like this. How? We will write system dot out dot print f. You have to use println. Okay, now there is a way. You write, for this is for new line. Okay, now %d. Already we are using in uh, C, right? Space percent O for octal, and %x. Okay, comma AB, comma AB, comma AB. For AB only. Okay, this is the placeholder for decimal. This is the placeholder. This value will be there for this octal, and this value will be used for hexa. Okay, now we will try to compile this. See, this is the corresponding value for what is the value? AB value is 8. Okay, for this is okay, in directly it is printing in decimal value. Okay, and what is the corresponding octal? Octal is 253176. 253176 earlier we have printed, so here also we have printed, right? And hexadecimal for AB. Hexadecimal for AB is from here to here. Already we have known this. Okay, so this is another way how you can print the octal hexadecimal. Okay, all these kind of format you can print it like this. Okay, and yeah, so and if I will write, and at last, because cursor is not going moving to the next line, so that's why what you can do, you can do system.out.println, simply blank. Okay, so it will go to the next line. This is for one line gap. Okay, so Control S, compile it and run it. Okay, here remove this lesson. Already I have used it here now, that's why. Okay, if you can remove it here, then you have to add it here. Clear? Now if I want to print pi value, okay, there is one, there is one pi, right, in mathematics. So if you want to print, there is one class called math is one class, and there is one constant available inside the math class called pi. Okay, you print it. What is the value of pi? Tell me guys, what is the value of pi? 3.14. Okay, see here. Oh, sorry. 3.14159. Okay, this is what the exact value available. So that's all guys for today's class, and we'll see tomorrow with some new things, operators. Okay, we'll start tomorrow operators. And if you are facing any difficulty, any doubt, you can please let me know, or you can directly comment it out on the YouTube channel. Okay, under the video, while watching the video, if you are having, while watching my class, if you are having any doubt, you can comment it out there. I will resolve that query to you. Okay, fine guys. While commenting, you can mention your name at last. Yeah, so Akancha is asking, now I am having some doubt. We were not using I in case of long integral. We were not using L. Why we were using, right? We were using L. Yes, we were using L. See here. Okay. Suppose. Yeah. If you are using long data type, if you are using long data type L, okay, and there is some long value. Okay, this is long value. Now by default your JVM will consider this value as int value. Okay, if it is considered int value, in this case you will not get, see here, you will get the issue integer number too large, because it is integer. Because JVM is understanding this is integer value, but the condition of integer value is it should be in the range, but it is out of range, right? So that's why you have to use either L or capital L. Okay, now what you are asking, no, in case of long AB is equal to 50, L is not mandatory. Yes, because 50 is what type? Can you please tell me quickly? 50 is of type what? Int. Akanksha, you tell me. Long AB is equal to 50. What is the problem? It will compile, right? There is no need of saying L explicitly. Why? Because this 50 is of type int, and int can be stored easily into the long data type. But in case of float F1 123.45, yes, because it's a double type. See, here it's a int type, so it is compatible to long, but here it is double. See here, I'll print it here. Float f1 is equal to 123.45. okay, you have to explicitly say that this is the float value. If you're not saying this, okay, compiler will treat this as a double value. By default it's the double value. Okay, by default is the double value, and you're trying to assign into float. That's why f is mandatory here. You have to use f or capital F. But in case of here, what is the type of the data? Int. And you are trying to store into long. That is compatible, right? It is compatible type. Yeah. So Akansha, so what? Float is also of type double, na? Okay. So no. See, you remember this. What is the memory structure? Float is taking how much byte? Can you please confirm? 4 byte, right? And double is how much byte it is taking? 8 bytes. Then how it is possible? You are trying to, okay, you are trying to allocate, you are trying to store the data, 8 byte of data into 4 byte. How it is possible? Correct? It is not at all possible. But in the case of int, it is taking 4 byte. In the case of long, it is taking 8 byte. uh, okay, and if you are trying to store 4 byte data into 8 byte, it is possible. You are trying to store 4 bytes of data into int. It is possible, right? Correct, Akanksha? Now everything is clear. I don't want a single doubt also in your mind. Not only, I mean, everybody. I'm actually having very concern about it, because if you're having a single doubt here at this point in time, later, okay, later when I will discuss further, I mean, in future we will discuss some more topic. That time these things will be used. I will be using frequently there. Okay, that time I will not explain each thing, each and everything again and again in detail. Okay, so everything has to be very clear. Okay, so I will again repeat it. Don't worry. See here, long ab is equal to 50. That is perfectly valid. You don't have to explicitly say that l. No, here it is not required. Why? Because this 50 is int type, and int is taking 4 byte. Okay, and you are storing into long type, which is taking 8 byte. Correct? It is compatible type. It is compatible. It is compatible. But here, see, if you're not defined as f, okay, 123.45, it is of type double by default, and you are trying to assign double into float type, which is taking 4 byte. Float is taking 4 byte, double is taking 8 byte. You are trying to assign 8 bytes of data into 4 bytes, right? That's why it is incompatible. Clear? Okay, so now we'll see here. We'll get the error. See? Okay, for that, float is required. Okay, and see here, AB is already defined. Let me define it again with different name, AK suppose. Then there is no problem. Okay. Okay. So any doubt, guys, now up to here? Okay, so we have seen different literals. Also, we have seen the use of Java P tools also. This is the first class where we used Java P tool. Remember this. Okay. So that's all, guys. So thanks for joining my session, and good night. We'll discuss operator concept tomorrow's class in tomorrow's class. Okay, cool.